Next reaction is called anti-dihydroxylation, right? So what's going on here? So di means two, hydroxyl group, so there's an alcohol. So adding OH across alkene, and they are anti-addition. See that? So one of them is wedge, the other one is dash, right? So you get trans diol. So they are trans to each other, and diols mean there are two alcohol. One alcohol is all. Right, methanol, ethanol, that's all. So diols mean two. All right, there are two steps here. The first step is called epoxidation. So to make an epoxide. So a three-membered ring oxygen is called an epoxide. You will learn this later in the field chapter ahead of us, but you will say first time in here. Okay, this guy will come back. All right, so to make an epoxide, you will need a peroxy acid. Anything you heard the word peroxide, that's not reactive. They got too many oxygen in it. Like hydrogen peroxide that we use to clean our cut, the paint, not the paint, so usually just a cut, anything that bleeding in your body, you put hydrogen peroxide on it. But hydrogen peroxide, it decomposes over time. You let it sit at room temperature, right? So my point is anything peroxide is not stable, which means that it's reactive. Okay, so adding peroxide to make an epoxide ring. And the other one, just an acid catalyzed ring opening. This is actually just a proton transfer and SN2. You can draw this mechanism easily. Okay. All right. Let's take a look what actually control the trans diol. Why do we get anti-addition here? All right. All right. If you remember, alkene is flat. Peroxide comes in here. All right. So the active oxygen right there. Nucleophilic attack. And then from epoxide, so proton transfer, this oxygen attack that carbocation, so you get an epoxide ring, and it's enantiomer. Okay, how do you get an enantiomer? Let's take a look. If this peroxide comes from the top, approaches from the top, you're gonna get epoxide pointing to the top. That wedge and wedge. If the epoxide comes from the bottom face, you're gonna get its enantiomer. That's how you get an enantiomer, basically. All right. Now the next, so that's the first step, make an epoxide. The second step is an acid catalyzed ring opening. Let's see how that works. Right. So we add an acid. So this is an acid catalyzed protonation, of course, right, and sulfuric acid or whatever. So you get protonated epoxide, which is even more reactive than just regular neutral epoxide. And reactive, go to react with water right away. So attack at a more substitute carbon, right? So that's more stable than attack on the other carbon. And you're going to open the ring. All right. So water goes to this carbon, This is water. Now used to be water, right? And the oxygen of the epoxide right there. Okay. And you can guess that, right? The last step is going to be deprotonation. Keep everything neutral. And anti-addition. All right. So what controls the stereochemistry? Again, this guy right here. See that? Because water have to attack from the other side. That's why you get an anti-addition. Yeah, water cannot attack from the top face. This guy blocks it. All right. A little bit about the peroxide. The common peroxide to use in this reaction are meta-chloroperoxybenzoic acid. Right. The word meta right here refers to a position on the benzene ring of the functional group. So this is the functional group. All right. So the first position of so this is the carbon that have functional group. The first position, all of it, that's an ortho, meta, and then para. Right? You can go the other side too. This is ortho, meta, and para. So the functional groups right here, this carbon with the functional group, ortho, meta, para. So that's why we call it meta, so chlorine on the meta, peroxy, so too many oxygen. Benzoic acid. Benzoic acid is just a benzene and then carboxylic acid sticking out of it. So MCPBA, that's what we call it. Or peroxyacetic acid. A regular acetic acid doesn't have this oxygen, the red oxygen. Those are reactive oxygen. Okay. All right, predict the products from here. So, all right, first step, adding MCPBA and then ring opening. Yeah? So, adding MCPBA, you're going to get a neutral epoxide. Adding an acid to protonate the peroxide, and then water will attack at the more substitute carbon. So you should get that. right? So oxygen at the behind it. Peroxide from in the epoxide, so this oxygen on wedge, still on wedge, you know that, and oxygen coming in from the back, go dash. All right, all right. Come down here. So this one we add peroxyacetic acid, yeah, and then ring opening later. Same thing, from the ring first, right, and then water attack. So you should get this compound, dihydroxylation, right? I don't show stereochemistry of this carbon because this carbon is not chiral center. Okay. All right. Last one more time before we go further. So review anti-addition. What make a reaction goes anti-addition? Any anti-addition reaction, they all have similar intermediate. They all have a 3-membered ring intermediate. Right, and that require an incoming nucleophile to attack from the other phase. So let's say this is top phase, nucleophile have to attack from the bottom. Okay, all of them have this 3-membered ring. Okay, all right, let's go to the next one. This one going to be Syn Dihydroxylation.